Imagine a place in the universe where gravity is so strong, not even light can escape. A place where the very fabric of space and time is warped beyond recognition. Sounds like science fiction. Well, it's not. Welcome to the mind-bending world of black holes, the most mysterious and extreme objects in the universe. Did you know that at the center of almost every galaxy, including our own Milky Way, lurks a supermassive black hole millions, sometimes billions, of times heavier than our sun, and yet, we can't see them directly. They're invisible, cloaked in darkness, but their presence shapes galaxies, dictates the motion of stars, and maybe, just maybe, could unlock secrets of other universes. Today, we're going to dive into what black holes really are, how they form, the different types that exist, what makes them so strange, and some of the most exciting recent discoveries, including images from the Event Horizon Telescope and gravitational waves from colliding black holes. Before we begin, let me ask you, have you ever wondered what would happen if you fell into a black hole? Or whether black holes could be portals to other universes? Let's explore together. At its core, a black hole is a region in space where gravity has become so intense that nothing, not even light, can escape its pull. Because of this, black holes appear completely black. But how can something like that exist? To understand this, think about gravity itself. Gravity pulls you toward Earth, keeps planets in orbit, and holds galaxies together. But if you compress a mass into a small enough volume, gravity at its surface grows stronger and stronger. When a massive star collapses under its own gravity at the end of its life, it can shrink to a point where escape becomes impossible. That's a black hole. Surrounding every black hole is a boundary called the event horizon, the point of no return. Once you cross this line, you're doomed to fall inward, and nothing, not even information, can come back out. Think of it like falling into a waterfall. Standing upstream, you can paddle away, but once you pass the edge, the event horizon, you're going over no matter what you do. But what's inside a black hole? What happens at its very core? The answer is both fascinating and perplexing. All the mass is thought to collapse into a single point of infinite density, the singularity, where the laws of physics as we know them break down. So how exactly do black holes come into being? The most common way is through the death of a massive star. When a star at least 20 times heavier than the Sun reaches the end of its life, it runs out of fuel for nuclear fusion, the process that counteracts gravity. When this happens, the core collapses, and if the mass is high enough, it compresses into a black hole. But not all black holes are born this way. Some black holes are primordial, theorized to have formed shortly after the Big Bang from extreme density fluctuations in the early universe. Others, known as supermassive black holes, are found at the centers of galaxies and weigh millions or even billions of solar masses. How they grow so massive remains one of astronomy's great puzzles. Did they start as smaller black holes and grow over billions of years, or did they form directly as giant objects? What do you think? Could supermassive black holes have existed since the dawn of time? And then there are intermediate mass black holes, a rare class that might bridge the gap between stellar and supermassive black holes, and micro black holes, hypothetical tiny black holes that could be smaller than an atom, though we've never observed one. Let's break this down. Stellar mass black holes, born from collapsing stars, these range from a few to tens of solar masses. Intermediate mass black holes, their existence is still debated, but they might have masses ranging from hundreds to thousands of suns. Supermassive black holes, found at the centers of galaxies, with masses from millions to billions of solar masses. Primordial black holes, hypothetical black holes formed in the first seconds after the Big Bang. Each type raises its own mysteries. For instance, why are intermediate mass black holes so elusive? Could primordial black holes explain dark matter? Black holes have some truly mind-bending properties. First, there's the event horizon, that invisible boundary we mentioned earlier. If you fell toward a black hole, an outside observer would see you slow down and freeze at the event horizon, while your image became increasingly redshifted and dim until you disappeared. But from your own point of view, you would continue falling inward, toward the singularity. Then there's gravitational time dilation. Time itself runs differently near a black hole. The closer you get, the slower time passes relative to someone far away. If you orbited near a black hole and then returned to Earth, you could find that far more time had passed on Earth than for you. Essentially, a kind of time travel into the future. And let's not forget Hawking radiation, proposed by Stephen Hawking, This process suggests that black holes are not truly black. They slowly radiate energy and can, in principle, evaporate over incredibly long timescales. This means black holes aren't eternal. They might one day simply evaporate and disappear. In 2019, humanity saw the first ever image of a black hole's shadow, the supermassive black hole at the center of galaxy N87. Thanks to the Event Horizon Telescope, this was a monumental achievement that confirmed many predictions of Einstein's theory of general relativity. And in recent years, LIGO and Virgo observatories have detected gravitational waves, ripples in spacetime itself, from merging black holes, opening a brand new way to listen to the cosmos. Even today, missions like NASA's NICER and ESA's Athena are helping us probe the environments around black holes in unprecedented detail, revealing their feeding habits and how they shape their surroundings. What do you think we'll discover next? Could black holes help us unlock quantum gravity, or even reveal the existence of other universes? Black holes aren't just cosmic monsters lurking in the void. They might also hold clues to some of the deepest mysteries of the universe. For instance, physicists are wrestling with the information paradox. What happens to information that falls into a black hole? According to quantum mechanics, information can't be destroyed, but a black hole seems to erase it completely. Could this paradox hint at a more fundamental theory that unites gravity and quantum mechanics, a theory of everything? Some scientists even speculate that black holes might connect different parts of the universe or different universes altogether through wormholes, hypothetical shortcuts in spacetime. Have you ever wondered, could a black hole be a gateway to another universe? While this idea remains speculative, it inspires physicists and science fiction writers alike. If black holes are black, invisible by definition, how do we even know they exist? Astronomers detect black holes by their effects on nearby matter and light. When gas and dust spiral into a black hole, they heat up and emit X-rays, which we can detect with space telescopes like NASA's Chandra X-ray Observatory. In binary star systems, a black hole can feed on its companion star, pulling material into an accretion disk that glows brightly in X-rays before the matter crosses the event horizon. At the centers of galaxies, supermassive black holes power some of the brightest objects in the universe, quasars, blazing beacons visible across billions of light-years. And of course, gravitational waves from colliding black holes give us a whole new way to observe them without relying on light at all. In fact, there's a supermassive black hole right in our own galactic neighborhood, at the center of the Milky Way, about 26,000 light-years from Earth. It's called Sagittarius *, and it's about 4 million times more massive than our Sun. In 2022, astronomers unveiled the first ever image of Sagittarius *, again using the Event Horizon Telescope, giving us a direct look at the heart of our galaxy. While it poses no danger to Earth, this black hole has helped scientists study how supermassive black holes interact with their environments and how galaxies evolve around them. Black holes play a fundamental role in shaping the cosmos. They regulate galaxy growth, influence star formation, and may even help explain how the large-scale structure of the universe evolved. When two black holes merge, they release a titanic burst of gravitational energy, rippling spacetime itself. These cosmic events are so powerful that the energy output can briefly exceed that of all the stars in the observable universe combined. And yet, these mergers are silent and invisible to our eyes, unless we use detectors like LIGO and Virgo to hear their gravitational waves. So, let's recap what we've learned today. Black holes are regions where gravity is so strong that nothing can escape, not even light. They form primarily from the collapse of massive stars, but some may have formed right after the Big Bang. There are different types: stellar mass, intermediate mass, supermassive, and primordial black holes. Their properties, then the very nature of space, time, and even information. Recent discoveries, like the first images from the Event Horizon Telescope and gravitational wave detections, are giving us new tools to study these cosmic mysteries. But there's still so much to learn. Could black holes reveal the secrets of quantum gravity? Could they teach us about the origins and fate of the universe itself? What do you think happens inside a black hole? Share your thoughts in the comments below. I'd love to hear your ideas. And if you enjoyed this journey into the darkest corners of the cosmos, don't forget to subscribe for more amazing videos about space, science, and the universe. Check out the links in the description to learn more about the Event Horizon Telescope, LIGO, and other cutting-edge missions studying black holes right now. Until next time, keep looking up and keep wondering.